In this session, we'll look at annuities. First of all, the definition of an annuity. So it is a series of payments made at equal spaced intervals of time. And if all the payments are identical, then we term it as level annuity. So there are actually a lot of examples in our daily life about annuity. So if you take a car loan, if you have a home mortgage, that's all examples of annuities. So if we have a level annuity and you are expected to make identical payments for every period, and you are going to make several periods to pay off your debt. So if we draw this or illustrate this process on the timeline, what you can see is that assuming we are now standing here at time 0, and we are expected to make a amount of payment at the end of each period. So you're going to make one payment at the first period, then another payment at the end of the second period, then we do this so on and so forth until the very last payment, which is the total, the nth payment. So the total number of payments here you made is n, and for each payment, the amount is a. Okay, so remember this setting, and we'll go to the next page to explain the application of this annuity. I think you are faced constantly with this kind of the options. For example, if you walk into a car dealer and the dealer offers you, say, if you want to buy the car with cash payment, and your offer is $25,000, but instead you have another option, which is take a car loan, and you will pay off your debt in, say, 3 or 5 years of time, and for each month you expect to pay $800 or $1,000 kind of payment. So when you see these kind of options, and think a lot of times we just do a quick calculations, we work out what's the total payment we need to make for the next 3 or 5 years if we take the loan, and what's the kind of total of the cash payment. I think one thing we always forget in this process is that we forget time value. Right? So really, we're not comparing apple to apple. So what we need to do here is we need to convert those future payments into kind of the current value. So we will be able to compare what the real kind of implication is for both options. To do that is actually not very difficult, right? So if you think of the total present value of the future series of payment, what you need to do is to convert them into the present kind of dollar. Right, so you're making one payment here at the end of the first period. Right. So let's assume the interest is R. Then to convert this payment here, this A first period to the present value, is to use it divided by 1 plus R. So that's for the first period of payment. And for the payment of the second period, remember from the previous sessions, you need to divide the payment amount A by 1 plus R to the power of 2, then you convert the third, the fourth, and all the way to the nth payment to the present value. Then add them together, then will be total of your present value. So this can be extremely long equation if we're making, say, in the case of home mortgage, right? So 30 years mortgage, then you're going to make 360 payment in total. So it will be pretty long. So how do we calculate that very quickly rather than just add all these elements together? What you can do is that you can do a little bit mathematical trick here. So you can multiply this equation with 1 plus R on both ends. So if you do that to the left side, then the value becomes present value times 1 plus R. And if you do that to the right hand side, you notice here this become A, and the second element here become A divided by 1 plus R. And the very last one, very last one become A divided by the 1 plus R to the power of n minus 1. So this will be the kind of new equation. Now you have these two equations. What you can do is that you use the second equation to minus the first equation. So on the left-hand side, you will get PV 1 plus R minus 1, right, which is this value here minus PV, right? So that's what you got here. On the right-hand side here, just pay a bit attention, is that you see those elements matching each other, right? A divided by 1 plus R, A divided by 1 plus R squared. The only exception is that the first A in the second equation and the very last element in the first equation, they're not matching, right? So there's no matched item. So what will happen is that all the rest will go, and what you have is A minus A divided by 1 plus R to the power of n. So you got this. Then you just convert this to the right-hand side. You got the present value is A divided by R, then times 1 minus 1 divided by 1 plus R to the power of n. Right? So that's how you calculate based on the monthly payment or payment of each period, the interest rate, and the total number of payments. How you convert them quickly into the present value. Luckily, nowadays, we do not have to do this manually. We do not have to write a very long equation to calculate this. We can use Excel to help us do the calculation. So what you can do is here, you can use the function in Excel, PV, and you just need to provide the parameters for this function. The first one here, interest rate. The second one here is the total number of payments. So if it's a 5-year monthly payment car loan, the total number of payments will be 60. If it's 30-year house mortgage, then the total number of payments will be 360. Then the third element or parameter here is PMT, which is the payment made each period. Right? So this is your monthly payment. So you type in 3 parameters, then you will get the present value of your series of payments. By using this formula, you will be able to compare, okay, what's the present value of your kind of mortgage or common payments compared with the cash offer is, and you will be able to make a more informed decision. Of course, the challenge of using this function is that to know the rate. Right? So in the case of mortgage or car loan, you know that, but in the case of just the inflation, then it is really challenged to have to make some assumptions. So just to summarize very quickly, in this session, we talk about the annuity and how to convert the future series payments into its present value.